Hi, today we're going to talk about a paper out of ETH and Cambridge, and it's titled On the Probability Equality Paradox in Language Generation. We've seen several neural language models that are trained on millions, if not billions, of lines of human text, and we assume at some intuitive level that high probability generations are going to be human-like. Surprisingly, what we're seeing is that high probability texts that these popular models are generating are usually not those assigned the highest probability by the model. So this begs the question, why does the lower probability text produced by stochastic decoding methods outperform text generated using probability maximizing approaches? And this is at the heart of what this paper is trying to address. To explain this phenomenon, they present this hypothesis, which is the expected information hypothesis, which is that text perceived as human-like should have an information content within a small interval around the expected information, i.e. the entropy of natural language strings. Pictorially, it would look something like this. If you were to draw a chart of the quality of words or text generated versus or against the probability of words chosen by the model, previously we assumed to some extent that this would be a strong positive correlation, and that we are. But what this hypothesis is trying to say is that there is an inflection point. So the graph wouldn't necessarily look like this, but instead it would look like this. And the optimal kind of region where the words are going to be sounding to be of high quality would be something in this region near the inflection point. The intuition for this hypothesis stems from the way we use language on a day-to-day basis. And that's discussed in this part. Language is used as a means for transferring information, and this property of language has in fact motivated several theories of language evolution. So some have posited, for instance, that natural language is developed to optimize for reliable and efficient data communication, subject to cognitive resources. And what does all of this imply? It kind of implies that when we communicate with each other, we tend to produce strings with a certain amount of information. And on the receiving end of communication, your listener is also expecting similar strings. And this expectation of information is at the core of the hypothesis presented by the authors. More formally, what they're positing is that in the expected information hypothesis, text perceived as human-like typically encodes an amount of information close to the expected information content of natural language strings. And we'll try to unpack this a bit more when we look at the results graph later on. But in order to test this hypothesis, they run a bunch of experiments on two tasks. The first being abstractive summarization, and the second, story generation. In the experiment setup-wise, it's pretty straightforward. They have two models, GPT-2 and BART, both Hugging Face implementations, and they attempt to show in several figures that human-like strings typically have negative log probability close to the expected information content of the probabilistic model from which they were generated. And we can see this quite obviously from figure 1. So if we look at figure 1, what it's trying to show us is, if you look at the pink region, that's the distribution of information, IY values of the model. And the green is for the reference strings, and the blue is for the bottom one of the model generated strings, and the yellow is for the top one strings. So from figure 1, we can see the pink region, the green region, and the entropy dotted line are both more or less coinciding with each other. But I personally would like to see a couple of other evaluations. For one, I did find the figure in the appendix rather interesting, and the figure is this one. What you're looking at on this chart, I believe, is a plot of the information IY for the different decoding strategies. It would have been nice to see a bit of a write-up explaining the following figure. And it would be nice to understand better as to why we're seeing different peaks for the different decoding strategies. And for story generation, I would be curious to understand how well the expected information hypothesis can predict and explain misspun tales. So I believe for the human evaluations, they only focus on measures such as fluency and naturalness for story generation. And a natural sounding story goes beyond the questions posed in the paper, and particularly, does the text seem to be natural English text? They would have to probably consider character intent, among other things. And I think one last thought that I did have of the paper is a lot of the evaluation was restricted to BART and GPT. It would be nice to see, while these charts like Figure 1, would differ for different types of models, and what kind of differences can we expect, and how should we be thinking about those differences? Those are some of the thoughts I'm left with after reading this paper. It was a pretty short paper and a rather interesting one. Um, to say the least, it was thought provoking. Made me think more about how we measure and pick words in language generation models. Let me know in the comments what you thought about this paper. See you next time.